The Milky Way is what astronomers call a barreled spiral galaxy, a great, slowly turning wheel of light, stretching roughly 87,000 light-years from edge to edge, yet barely 1,000 light-years thick in its flattest reaches. Between 100 billion and 400 billion stars live within it, and quite possibly a similar number of planets. Our own Sun occupies a modest position, some 27,000 light-years from the galaxy center, on the inner edge of a spiral arm known as the Orion Arm, a quiet and unremarkable address in a truly magnificent cosmic city. At the very heart of that city lies something extraordinary, a supermassive black hole, Sagittarius A, with a mass 4 million times greater than our Sun. It draws in matter at a slow, impatient rate, resting quietly like a sleeping giant, while stars and gas wheel endlessly around it in orbit that spans millions of years. The Milky Way's disk is not perfectly flat. It bends and wraps gently as it stretches outward, twisting into a graceful S shape at its furthest edges. Surrounding this great disk is a vast, roughly spherical halo, filled with ancient stars and dense globular clusters, some of them nearly as old as the universe itself. And beyond even that lies an invisible sphere of dark matter, mysterious and unseen, yet exerting its gravity on everything within. Scientists believe this dark matter, halo alone, may hold more than 1 trillion times the mass of our Sun. Beyond our galaxy's edges, the Milky Way is not alone. It belongs to a family of roughly 50 galaxies called the Local Group, which belongs in turn to the Virgo supercluster, which is itself part of the Colossal Laniakea supercluster, a structure stretching across hundreds of millions of light years. You're nested inside nested worlds, each one more immense than the last. Thanks to the European Space Agency's Gaia spacecraft, one of the most remarkable astronomical missions ever undertaken, we now hold the most detailed map of the Milky Way ever assembled. Positions and distances for over 1 billion stars, measured with a precision 1,000 times greater than what was possible just 30 years ago. What was once a mysterious pale smear across the night sky has slowly and painstakingly began to reveal its true shape. Centuries of wandering. For most human history, that pale band of light was a mystery. Aristotle believed it was part of Earth's own atmosphere, fiery vapors he imagined left behind by burning stars above. Centuries later, the philosopher Olympiodorus the Younger challenged this. If the Milky Way truly lived within our atmosphere, he argued, it would shift and change depending on where you stood and what hour it was. But it never did. From every place on Earth, it always looked precisely the same. It must therefore belong to the celestial realm. In 1755, the philosopher Immanuel Kant went further still, proposing that the Milky Way was an immense rotating disk of billions of stars held together by gravity, and that the faint, cloudy nebulae scattered across the sky might be other island universes, entire galaxies laying far beyond our own. He was right, but it would take nearly 200 more years to prove it. That proof came in the early 1920s. Two great astronomers, Harlow Shapley and Herbert Curtis, had debated passionately before the scientific world about the true nature of those spiral nebulae. Were they part of the Milky Way or entirely separate galaxies? The answer came from Edwin Hubble, who identified Cepheid variable stars within the Andromeda Nebula. Stars whose steady pulse and brightness allowed him to calculate their distances with remarkable precision. Andromeda, he found, lay some 275,000 parsecs from our Sun. The quiet spiral beyond Andromeda, some 2,730,000 light-years from Earth, lies the third great member of our local group, the Triangulum galaxy, Messier 33. Smaller and quieter than either of its great neighbors, it stretches some 61,000 light-years across and holds approximately 40 billion stars. The most spectacular of its stellar nurseries is a cloud of ionized hydrogen known as NGC 604, a region 1,500 light-years across, shining with a brilliance 45 million times greater than our Sun. The second brightest star-forming region in our entire local group. Faint bridges of hydrogen gas, invisible to the eye but detected by radio telescopes, reach between Triangulum and Andromeda. Ghostly threads hinting at an ancient encounter between the two galaxies, perhaps 2 to 8 billion years ago. Astronomers believe that in approximately 2.5 billion years, they will meet again, far more dramatically and far more permanently than before. Whether Triangulum will be drawn into the great merging of Andromeda and the Milky Way or cast adrift into the dark between galaxy clusters remains one of the quiet, open mysteries of our cosmic future. When we look up at the night sky, when we trace that soft arc of the Milky Way above a dark and open field, we are looking at something that has been forming for more than 13.5 billion years. A structure shaped by gravity and time, by ancient collision and slow creation, by the patient accumulation of matter across the entire breadth of cosmic history. At our galactic center, Sagittarius A waits quietly. Andromeda drifts toward us through the darkness. The Triangulum galaxy winds its spiral arms around 40 billion stars, building new suns as patiently as it always has. It is not the size of the universe that is most astonishing. It is that something so small, so brave, so fragile as a human being can look up into the darkness and begin, however slowly, however humbly, to understand it. If you enjoy exploring those mysteries with us, be sure to subscribe and join us for the next journey into the unknown. Until then, thank you for watching.